So now that we've had a lot of practice, hopefully, with going from the linear structures of the Fisher projections to the ring formation, we can now talk about disaccharides and polysaccharides and oligosaccharides, because these are formed when things are in the ring formation. So that designation of whether something is alpha or beta is very, very important to how we tell what the linkages are between two different sugars. Because once we make that linkage, we actually stop the ability to go back and forth between the linear structures. Because remember, when you have that linear structure and you want to go and you make alpha or beta, it's kind of a crapshoot which one you're going to be. And you can go back and forth and back and forth and back and forth and never know. But once you make it into a disaccharide, you effectively take that linkage and you keep it as alpha or you keep it as beta. So it cannot change anymore. So just a few couple quick in pieces of nomenclature, I guess. Disaccharides, di for two, so you have two sugars that are linked together. So this linkage between the two sugars here, this is what we call a glycosidic linkage. Oops, that's a C, not an S. This glycosidic linkage, what you have to tell there is you have to distinguish, is it alpha or beta, and you have to tell what carbon numbers in those sugars is it connected to. That's how we distinguish, right, what type of linkage we have, whether it's alpha or beta, and that can distinguish things like, for example, when we talk about polysaccharides, we talk about something called cellulose. Maybe you've heard of that before. Cellulose is found in trees and tree bark, or maybe you've heard of glycogen. Glycogen is what we use in like our fats and muscle stores for energy. Glycogen and cellulose are the exact same sugar. It's a polysaccharide, many sugars together, of glucose. It's just glucose, 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 over and over and over again. However, the difference is, in us, glycogen, we have alpha linkages, opposite. In trees, for cellulose, they have beta linkages. That is the only difference between them. So knowing that alpha and beta, I know it seems complicated and I know it seems very a small, minute kind of change, but again, literally the difference between us and trees is that OH group going up or is that H group going down? That's it. So again, when we make a disaccharide, so going back to disaccharides, we kind of skipped ahead to polysaccharides just to give you a little bit of a preview, but a disaccharide is two sugars coming together, okay? And we make a glycosidic linkage. So when we name these, we have to name the sugars and we have to name the type of glycosidic linkage. So alpha or beta, in addition to the names of the sugars, as well as what number carbons, that's why we talked about carbon 1, carbon 2, carbon 3, carbon 4, labeling those. We have to tell what carbons are we attached to. So, for example, if we take a look, if you've ever heard of lactose, or maybe you know somebody who's what we call lactose intolerant, meaning they cannot tolerate having lactose. Lactose is also known as a milk sugar. It's the sugar that we primarily find in things like ice cream and milk and things like this. Well, it is a disaccharide. It's two sugars together. So if you take a look at the slides here, it's two sugars, and those sugars are galactose and glucose. Remember, galactose and glucose are diastereomers. They differ at one chiral center only, okay? So it is D-galactose and D-glucose together, all right? However, if you take a look, the glycosidic linkage between them is a beta linkage, okay? So how we name these is we name sugar number 1. In the case of lactose, that sugar is galactose or D-galactose. So galactose is sugar number 1. Then we have to name, hey, is the glycosidic linkage between the two sugars, is it alpha or beta? So if you take a look at lactose here, you can see that the OH group is going up and the OH group on carbon 6 is going up. So they're going in the same direction. This is a beta linkage. So it would be galactose beta. Then we have to put what carbons are connected. Well, guess what? Galactose is an aldose, which means its carbonyl carbon is carbon number 1. So because it's carbon number 1, that will be the first number there. So carbon number 1 here, so we're going to put carbon 1 from galactose, and now we go to the next sugar. So we have that glycosidic linkage between carbon number 1 here, and it's connected to carbon number 4 on glucose. So we have galactose with a beta linkage. Carbon number 1 is now we go to the next sugar connected to carbon number 4, and then we name the next sugar, which is glucose. So the full name I'm not including the D's here, but you could do D's as well. D-galactose, so first sugar, beta linkage between carbons 1 from galactose and carbons 4 from glucose, 2 D-glucose. So you should be able to, if you're given the names of the sugars here, you should be able to name them. So let's say, for example, I'll do carbon 2, carbon 3, carbon 4. Let's say this is carbon number 5 here for whatever sugar I'm looking at. And let's say this is carbon number 1, 2, 3, 4, 5, 6. So we've got here a hexose bound to a ketose, okay? And so here the OH group, so H is going up, which means the OH is going down. So let's just call this sugar X-ose. So we would name this, and we'll name this sugar over here Y-ose, just to give you an idea, because I'm not pulling in the OHs and the H's to give you the exact names. But it's whatever sugar this is, okay? So we would name this X-ose, and now this linkage, OH is going down, this is going up, they are opposite. X-ose alpha, this is carbon number 1, connected to carbon number 5, 1, 5, and the final sugar is Y-ose. So if you're given a particular sugar or disaccharide, you should be able to give the full name. So again, name the first sugar, name the type of linkage, either alpha or beta, name the 2 carbons that are connected together, usually 1 and like 4 or 5 or 3 or 2, right? And then name the second sugar. So again, first sugar name, anomeric carbon designation, alpha or beta, the carbon number of the first sugar, the carbon number of the second sugar that are connected together, and what the name of the second sugar is. So you should be able to, using the homework and the questions in the back of the book, etc., for extra practice, be able to name a particular disaccharide. So here are some common names or common other types of disaccharides from your book. So again, we just did lactose, but let's take a look at sucrose. So what would be the full name of sucrose? Well, it's a glucose and a fructose together. So let's take a look at how we would name this. So again, we always name sugar 1, alpha or beta, carbon, sugar number 2. So if we take a look at sucrose, which you may recognize the name sucrose. Sucrose is also known as table sugar. So this is the kind of sugar like, that you get for like sugar in the raw, or just like sugar that you buy from the grocery store to bake with, etc., etc. Well, if you take a look, it's glucose and fructose. So we know our first sugar will be glucose, and our last sugar will be fructose. But now we have to take a look, and you can sort of zoom up on these slides if you want to a little bit, but just taking a look at what we have here. So here we have glucose, okay? That CH2OH group is going up for carbon 6, but the OH is going down. So they are opposite, which means that is alpha. And now we take a look. The glucose is carbon number 1 bound to carbon number 2 of fructose. So 1, 2, fructose. However, if you notice, in sucrose right here, there's also a beta because the anomeric carbon in sucrose, in fructose is carbon number 2. So you could name it the other way. So you could also name this going the opposite way if you wanted to. So you could name this fructose, but now fructose, if you take a look at fructose, you have to name the designated anomeric carbon. And that is a beta linkage. So it's fructose beta, and now you would do 2, 1, glucose. So sucrose is an example of a sugar where we actually connect the 2 anomeric carbons together. That's why one of them says alpha, one says beta. That's kind of a unique possibility. But if you take a look, you can try the example of the full name of cellobiose, but let's take a look at the full name of maltose. So without writing on the board, take a look, take a second, and then we'll go through it together. So if you take a look, maltose is just 2 glucose molecules. So the first name of the sugar would be glucose. And if you notice there, it's carbon number 1 to carbon number 4. So it'd be glucose. And that designation is alpha. So glucose, alpha, 1, 4, glucose. So again, sugar, anomeric carbon, number, sugar. So you should be able to, if you're given structures of a disaccharide with this kind of designation, be able to give the full name, okay, of that particular disaccharide. So now we're going to move on to talk about polysaccharides as a result.